Well, hello there, and in this video I'm gonna talk more about addition of vectors and vectors in one dimension. So let's do a quick recap. So whenever we say that we have a vector, uh, we have a vector. Suppose this is vector A. Suppose this is vector A. So we can represent this vector A by the magnitude of A along the direction of A. Okay, so we write hat on the top of the letter that is used to symbolize a vector in order to represent the direction in which it is going. So since we are talking about three dimensions here, and that we would require this a hat because we're gonna talk about that in we'll talk about it further. So uh, we can write this vector as the magnitude of the vector along the direction of a. So when we are talking about one dimensional motion, that only means that the object can move along the object can only move in one dimension, that is along a straight line. So that straight line can be slanting, that can be horizontal, or any direction you like, but that will always be a straight line. So the object cannot move sideways. The object can only if you consider this to be straight, if you consider this to be the line along which movement is possible. So that only means if there were a ball, it could only move along this direction. If you consider this to be the line of allowed motion, so as I would like to call it, line of allowed motion. So this would be the path. This would be the line along which the ball could move. So when we are talking about the direction of one dimensional vectors, so suppose this is a vector, and whenever we are talking about direction in one dimension, okay, we talk about positive and negative instead of some letters some the letters of the vector to represent the direction. So obviously there are only two directions in one dimension, okay, that is up or down. So that can be the other way around, that is left and right. So we gonna take upward and downwards here. So it's up to you. You can assume the negative as downwards and the positive as negative. You can take positive as downwards and negative as upwards, and you could do the other way around. So let's suppose this is a vector. I'll say this is vector B, and its magnitude is 5 units. Okay. So when we write this, how do we write it formally? We would write the magnitude of B along the direction of B. So clearly there is only one direction. There are only two directions, that is along the direction of B or opposite to the direction of B, that is upwards or negative or downwards. So instead of writing this part here, what we would do is add a plus to the magnitude that just represents it's going along the positive direction. So here we are assuming that the upward direction is the positive direction and negative is the downward direction. Okay, so what if I invert it? So we can say that we can represent this vector B as, since it is going in the positive direction, we would write the magnitude of it 5 units along the positive direction, or you can say the upward direction. So what if I were to uh, invert this vector right over here? So if I inverted this vector, okay, I'm gonna erase this, and if we inverted this vector, now how would you represent this vector? Since that vector was vector B along the positive direction, this vector is pointing completely opposite to it, and the angle between them we can say is 180 degrees. So when we invert the direction, that just becomes negative vector. Okay, so negative over the positive vector. So if if this was a negative, it would point to the upward direction, that is what we consider positive direction. Okay, so we can represent this as minus 5 units. Since upward was 5 units, we would represent this using minus 5 units. Now suppose this wasn't b, this was some arbitrary vector. Let's name it vector c, and still we are going to assume that upwards is positive and downwards is negative. So if there was a vector c, if and vector c is pointing downwards, so we would represent it the vector c as negative 5 units, since it is pointing downwards, and downwards is what we consider to be negative. Okay. So I hope you got an idea of what would vectors in one dimension mean. Now let's say if I have a vector, I'll do it in yellow. We have a vector. Okay, so I'll take simple letters here. We'll take A. So it's become a convention now. So as the magnitude of, and we are talking about one dimension, and we are gonna assume that the upward direction is positive and then downward direction is negative. So let's say this is positive 10 units. Okay, and suppose there's another vector pointing in the same direction as vector A, and that is the positive direction. Let's say this is vector B, and let's say it equals to 12 units, positive 12 units, of course, since they are both facing in the same direction. Now when you come to addition of vectors, so what we look at, the magnitude of the first vector, the magnitude of the second vector, and the angle between them. So clearly when we join the two tails of this vector, we get the angle between them as 0. So if I were to take this vector, okay, I'll take this vector. If I were to take this vector and just place it tail to tail attached with the second vector, so clearly you can see the angle between them is 0. So when the angle between them is 0, we could just if we want to find the magnitude of the resultant, okay, we could just add the magnitudes up, and we would get the magnitude of the resultant. So let's say not let's say we'll just solve it for this. So I'll just prove to you that whenever you got two vectors facing in the same direction in one dimension, we could just add their magnitudes up to get the magnitude of the resultant. So what is the formula for the magnitude of the resultant? That is c is the magnitude of the resultant, okay, equals to root of the magnitude of the first vector squared plus the magnitude of the second vector squared plus 2 times the magnitude of the first vector times the magnitude of the second vector times the cosine of theta. So what's theta here? What does theta means? That the angle we obtain after joining two tails of the vectors. So clearly we are getting the angle as 0 between them. So we could just replace this cosine with 0, cosine of theta with cosine of theta with 0. And what is cosine of 0? It's 1. So when you multiply 2ab times the cosine of theta, you get the same thing as 2ab. Okay, so we could write c equals a square plus b square plus 2ab. So you might recognize this as a identity. So what is this thing? A square plus b square equals to ab. You might remember from the basic algebraic identities that a square plus b square plus 2ab is the expanded form of a plus b the whole squared. A plus b the whole square, right? So these are the magnitudes of the respective vectors, and this power to 2 cancels out with this radical sign here, square root. Okay, so we get the magnitude of c as a plus b, and that's simply the magnitude of the first vector plus the magnitude of the second vector. So this is strictly for one dimension. Okay, so we cannot take it like, suppose there was a vector in this direction. We are not talking about one dimension in this case, 5 units, and there was a vector in this direction. Suppose this was 3 units. We could not add them up the same way did with the same way we did here. So we need to resolve, or we could solve it in some other method. So when we talk about the addition of vectors pointing in the same direction in one dimension, we simply take the magnitudes of the respective vectors and add them up to get the magnitude of the resultant. Now let's come to the subtraction of these vectors. So what does subtraction mean? If I were to take this vector and invert its direction. Okay, invert its direction, and take this vector too. I'll add this arrow on top of it. So when we add both of this, so it was initially vector a. Now since we have inverted the direction, we could write this as negative a, and we could represent this as negative 10 units. Okay, so what is this vector? That is vector b, and since it is along the positive direction, we would write plus 12 units. I need not add a plus again and again here. That's 12 units. So if you said you have to subtract this vector, so if you have to take the vector a out of vector b. So what does subtraction mean here is the addition of the vectors when one of the vectors is inverted. So if this were along the same direction, and if you were told to subtract vector a from vector b, all you would need to do is invert the direction of vector a. So since we have inverted it now, we would get vector a as negative 10 units, and if we add them up, it's the same thing as adding the vectors up when you invert the direction of a. So we would get the resultant, and there's one thing to notice: the angle between them. Okay, the angle between them, since we have joined the two tails of the vectors, we are getting it as 180 degree, right? Because it's a straight line, and motion along one dimension is always a straight line, always along a straight line. So clearly the angle between them is not 0 and it is 180. So when we take the magnitude of the third vector, we would get it as a squared, that is the magnitude of the first vector squared, plus the magnitude of the second vector squared, plus 2 times magnitude of the first vector times the magnitude of the second vector, times the cosine of theta. Now what is theta in this case? In this case it was 0, and in this case it is 180. So what is the cosine of 180? We know that from basic trigonometry, the cosine of 180 degrees is -1. So when we multiply 2ab by -1 by -1, we get the same thing as -2ab. So we could write it as a square plus b square. These are the magnitudes of the vectors. Instead of plus, I would write minus, because this thing is multiplied by -1. Okay, so multiplied by -1. So we could Okay, so we could write it as minus 2ab. So you can notice that this too resembles an algebraic identity, and it is the expanded form of a minus b the whole square. Okay, so we could write it, we could compress this as a minus b the whole square. Now these things cancel out, and we get the magnitude of the resultant simply as the magnitude of the first vector. Okay, the magnitude of the first vector minus the magnitude of the second vector. Okay, and in this case I have done a mistake. I have taken this vector. Okay, this vector as the first vector. I should have taken this vector as the first one. So it's alright. It does not matter that much. So all you would get is the magnitude in negative. So what does magnitude in negative mean? So when we are subtracting vectors, okay, subtracting vectors of the same unit, such as the velocity vectors, if we take the final velocity minus the initial velocity, we know that we get the change in velocity. So when we get the resultant as the resultant, that is c, as negative, that only means that the velocity is decreasing. Okay, so suppose the vector was 10 units before, and the vector now is 5 units. It only means that the change will be pointing downwards, since we are assuming that downwards is negative. So if we were to line these up head to head, I mean tail to head. Okay, so I would take the head of tail of the vector attached to the head of the vector, and what would be the change? This thing. Okay, I would erase the 180 degree. This thing, this tiny part we are getting, that will be the change. Okay, and since if we were to subtract vector a from b, that is the magnitude of b minus the magnitude of a, we wouldn't get something negative. And what does this if we are subtracting the magnitude of a minus the magnitude of b, we would obviously get a negative thing, and that just represents the change in the vector. Okay, so I hope you got an idea of what addition of vectors in one dimension mean, and how could you add them or subtract them. So and then that's enough for today, and in the next video I'll be talking about the resolution of vectors. Okay, and I'll give you a quick idea. So I'm not gonna write anything. So when we are talking about vectors, okay, two-dimensional vectors, we are not gonna take the third axis right now, because that's a bit complex, and might seem confusing as well. And when we talk about two dimension, we could represent any vector as the sum of other two vectors. If you're not getting what I'm saying, it's completely alright. I'll be explaining it in the next video. And if you have any doubts, please post it in the comments, or you could email me at the provided email ID in the description. So thanks for watching, and like, share and subscribe.